welcome back to Silent Science World, this quiet corner of the night, where we drift together into strange and gentle science. Tonight our path leads into the hidden universe of spiders, creatures found in every desert, every forest, every damp cave, every quiet garden, and yes, tucked into the corners of the very room you might be resting in right now. They travel on threads thinner than a single strand of hair, riding currents of wind high above the treetops. They build snares of astonishing precision, hunt with a patience most predators could never match, and sense their surroundings through senses so unusual they barely seem to belong to this planet. Some of them dance for a mate, some dive beneath the surface of ponds, some vanish entirely into the folds of a flower. Others feel the world arrive to them as trembling messages carried along silk. The deeper you look into their lives, the less ordinary they become. These are not simply small, many-legged creatures scuttling through the undergrowth. They are architects, chemists, acrobats, and survivors from an age of the earth so old it barely resembles the world we know today. Their silk can outperform materials our best engineers still struggle to replicate. Their eyesight, in certain species, is almost unbelievably sharp. Their hunting strategies can seem too clever for something so impossibly small. If this kind of slow, curious wandering through nature brings you comfort, feel free to like this video, subscribe to the channel, or leave a thought in the comments below. It helps this quiet corner of the internet reach other tired minds looking for somewhere peaceful to land. But none of that matters right now. All you need to do in this moment is let your body settle. Let your shoulders drop. Let your breathing slow and your eyelids grow heavy as we wander together into this hidden world. Let's begin. Pound for pound, a strand of spider silk can outmatch steel in raw strength, and that fact only becomes more astonishing the more you think about it. A spider's entire body might be small enough to rest on a windowsill, and yet from that tiny frame it draws out a fiber capable of absorbing enormous force without breaking. Engineers are fascinated by it because it manages something steel cannot. It combines toughness with flexibility. Steel is strong, yes, but it is heavy, rigid, and unforgiving. Spider silk bends. It stretches. It gives just enough to hold on. A single thread can absorb the impact of an insect striking it at speed, and it can do all of this while being far finer than a human hair. What makes it even more remarkable is the process itself. The spider produces this fiber at ordinary room temperature from a liquid protein mixture, without furnaces, presses, or factories of any kind. Nature quietly solved a materials problem that human industry still hasn't fully cracked. Every web catching the morning light is not just a pretty sight. It is a feat of microscopic engineering, spun fresh from a living body only moments before. Some spiders can travel for miles through open air without ever using wings. They accomplish this using nothing but silk, sunlight, and the invisible architecture of the atmosphere. A small spider will climb to an elevated point, lift its abdomen into the breeze, and release fine threads that catch and billow like miniature sails. For a long time, people assumed wind alone carried them aloft, but the truth turns out to be stranger than that. Scientists now believe that the natural electric field surrounding our planet may help lift these threads skyward, giving these tiny travelers an extra boost into the open air. Once airborne, spiders can drift for astonishing distances, across farmland, over rivers, even across open ocean. Sailors have reported spotting these small travelers landing on ships far from any coastline, arriving in places where no branch or web could possibly have carried them. It means that a spiderling hatched in one hedge might, by the end of the same day, find itself on a remote island or high on a distant mountainside. For a creature this small, the world isn't something defined by roads or trails. It's shaped by rising currents of warm air, invisible atmospheric forces, and long highways of silk suspended far above our heads. Spiders exist on every continent except Antarctica, and that single fact tells us a great deal. This is not a narrow group of animals confined to one kind of habitat. It's a lineage that has found a way to settle nearly everywhere life is possible. They wait patiently in dense tropical canopies, stalk prey across sun-baked dunes, hide beneath the bark of temperate forests, and endure freezing nights in high mountain passes. Some live in total darkness underground. Some patrol the banks of streams. Some have adapted so completely to city life that people share their homes with them for years without ever noticing. Their success comes down to sheer adaptability. They don't all hunt the same way, build the same kind of home, or chase the same prey. Evolution has shaped them into hundreds of different solutions to a single shared challenge. How does something so small manage to dominate so much territory? Only the icy expanse of Antarctica has managed to keep them out entirely. Everywhere else on the planet, the eight-legged experiment has succeeded spectacularly. A web can act almost like an ear, picking up sound through the vibration of its threads. Not through anything resembling ears, and not in the way our own hearing works, but with a sensitivity that borders on astonishing. A web isn't just a trap suspended in space, it's an instrument held under careful tension, ready to register the faintest disturbance carried through the air or along the silk itself. When a sound wave passes nearby, the strands quiver ever so slightly. A spider resting at the center, or perched along an edge, can feel those tremors through its legs and interpret them as meaning. One pattern of vibration might signal food, another might warn of danger, yet another might announce the arrival of a potential mate. Researchers have observed spiders reacting to distant sounds, crouching, turning, repositioning, before anything has physically touched the web at all. This suggests the entire structure functions as an extension of the spider's own senses, stretching its awareness well beyond the boundaries of its body. A web hanging quietly in the corner of a room is never truly passive. It listens, like a living net of nerve endings stretched across empty space. Certain spiders are able to regenerate a lost leg after surviving an attack. For most animals, losing a limb marks a permanent and often devastating change. For a young, still-growing spider, it can instead be the beginning of a recovery. If a predator manages to grab hold of a leg, the spider can sometimes detach it deliberately and escape, sacrificing a small part of itself to save the whole. Then after its next molt, a new limb begins to take shape. It may start out smaller and less refined than the others, but with each subsequent molt, it becomes more functional and better proportioned. This ability matters enormously in a life defined by narrow escapes. A hunting spider depends on balance, speed, and precise control. A web-building spider relies on exact movement across delicate silk. Regeneration offers a second chance in a world where a single mistake is often fatal, and it reveals just how dynamic a spider's body truly is during its growth. These animals are not locked into one unchangeable form. While they are still developing, they can rebuild themselves. For a spider, survival isn't always about avoiding damage. Sometimes it's about recovering from it. The very earliest known spiders predate the first dinosaurs, which places their origins in a world almost unrecognizable compared to our own. Long before massive reptiles ever roamed the earth, the ancestors of modern spiders were already part of life on land, moving through primeval forests and ancient landscapes. The continents themselves were arranged in configurations we would barely recognize today. Plant life was spreading in forms unlike any modern woodland, and insects were diversifying rapidly, opening the door for predators capable of following them onto dry ground. Spiders emerged as part of that vast transformation. They were among the earliest animals to turn barren land into a place where sophisticated hunting could occur. Fossils and ancient relatives trace the spider lineage back hundreds of millions of years, meaning they endured planetary upheavals, dramatic climate shifts, and mass extinctions that wiped out countless other branches of life. So the next time you spot one paused quietly in a doorway or tucked beneath a leaf, understand that you are looking at an ancient survivor from a lineage older than the dinosaurs themselves. Some spiders can construct a fully functioning trap with astonishing speed, fast enough that prey barely has a chance to register what's happening. Timing matters when your next meal can simply fly away. Many web-building species don't scatter silk randomly. Instead, they follow remarkably efficient sequences, laying down frame lines, support lines, and spirals in an order that transforms open space into a working trap within a short stretch of time. An orb web can appear seemingly overnight between two branches where nothing existed the evening before. By dawn, it is already tuned for impact, anchor points chosen, tension adjusted, and the sticky capture spiral arranged so that any insect arriving at speed will be slowed, held fast, and detected through vibration almost instantly. Some species can also rush forward and wrap struggling prey with breathtaking quickness, pinning down wings and legs before real resistance can build. To our eyes, a web might look delicate and motionless. In practice, Its fast-acting architecture, built by an animal that understands timing better than many far larger hunters ever need to. Inside a spider's body, silk begins its life as a dense, protein-rich liquid, stored in specialized glands and waiting for the moment it's called upon. When the spider draws that material through its tiny spinning organs, the internal chemistry shifts almost instantly. Pressure changes, water is drawn out, the proteins align and lock into place. What emerges is no longer a liquid at all. It's a finished, ready-to-use fiber, produced without roaring machinery, without extreme heat, and without any workshop larger than the spider itself. Scientists study this process with something close to envy, because humans still struggle to manufacture fibers this strong, this light, and this efficient under such gentle conditions. A spider requires no factory to produce an advanced material. It carries the entire manufacturing process inside its own body and releases the finished product into the world exactly when it's needed. Not every spider relies on a web to catch its meal. The classic image, a spider waiting patiently at the center of a trap for something to blunder in, is only one small part of the story. Many species abandoned the passive trap entirely in favor of active pursuit. Wolf spiders chase down prey across open soil and fallen leaves. Jumping spiders stalk with remarkable control before launching themselves with pinpoint timing. Crab spiders lie in wait inside flowers, striking at close range. Some species even raid other spiders' webs, stealing meals or attacking the resident outright. This matters because it shows just how flexible spiders have become over evolutionary time. Silk remains useful in countless ways, but it doesn't always have to become a snare hanging in open air. It can line a burrow, protect a clutch of eggs, or serve as a safety line while a hunter explores unfamiliar terrain. The spider world isn't built around a single method. It's full of different hunting philosophies, each shaped by habitat, body design, and opportunity. Watch a jumping spider stalk its prey, and the comparison to a stalking cat starts to feel earned. It doesn't wander aimlessly until it happens to bump into food. It watches carefully, it shifts its position, it creeps forward, pauses, then circles for a cleaner angle of attack. If the most direct path looks unfavorable, it may take a longer detour across leaves or stems, briefly losing sight of its target while working toward a position that offers a better strike. This is what fascinates researchers most. Some spiders appear capable of holding a goal in mind while navigating an indirect route toward it. Then comes the final launch, powered by internal hydraulic pressure and guided by remarkably precise depth perception. The strike itself is sudden, but the calculation leading up to it can be surprisingly deliberate. In an animal whose entire brain could fit on the tip of a finger, that kind of behavior feels almost magical, and it reminds us that intelligence doesn't always require a large body to exist. Wolf spider mothers carry their newly hatched young on their own backs for days at a time, one of the most startling images the spider world has to offer. At first glance, a mother wolf spider moving across the ground looks entirely ordinary. Then the light catches her differently, and you realize her body is covered in tiny spiderlings riding along like a living cloak. After hatching, the young climb aboard and remain there while she continues hunting and moving through her territory, carrying them across soil, stone, and fallen leaves during one of the most vulnerable stages of their lives. This is not the behavior of a careless creature scattering offspring and hoping for the best. It's active, visible parental care, in a group of animals often imagined as cold or purely mechanical. Peacock spiders raise brilliantly colored fans and perform elaborate dances in the hope of winning over a mate. These spiders are tiny, but their courtship displays are anything but modest. The males carry vividly patterned flaps on their abdomens, often glowing with reds, blues, oranges, and iridescent shimmer that seems far too bold for such a small creature. When a female is nearby, the male raises those flaps like a fan, lifts his legs, and begins a performance that is part dance, part signal, and part gamble. He waves, vibrates, sidesteps, and flashes color in a carefully timed sequence. If the performance impresses her, he may survive long enough to mate. If it fails, he risks being ignored, or worse, attacked. That danger is part of what makes the whole display so dramatic. On a stage smaller than a fingernail, a full courtship performance unfolds with all the tension of a theatrical production. Trapdoor spiders build hinged burrow entrances so cleverly disguised they can vanish into the landscape entirely. Along the edge of a path or hidden in bare soil, there may be a tiny door so perfectly camouflaged that you could stare directly at it and never notice. These spiders dig burrows, line them with silk, and construct a fitted lid from soil, plant fragments, and webbing. Closed, it blends seamlessly with its surroundings. Beneath that lid, the spider waits in a narrow shaft, front legs poised near the entrance. When something wanders close enough, the door bursts open, and the strike is immediate, prey and predator both vanishing underground in an instant. These burrows can last for years, becoming fortified homes offering protection from weather, predators, and extreme heat. The spider is both architect and ambush hunter, transforming a hidden chamber in the earth into a machine built purely for surprise. Many orb-weaving spiders rebuild their webs from scratch nearly every single night. A web can look like a finished, permanent structure. But for many of these spiders, it's closer to a daily project, begun again and again. By morning, the silk may already be damaged, dusty, or stripped of its stickiness by wind, pollen, and the impact of countless failed attempts. So the spider takes it down, often consuming much of the old silk in the process, and begins fresh when conditions allow. New anchor lines are laid, the frame is tested, radial lines extend outward, and the capture spiral is added in widening circles until the entire geometric structure hangs ready. This nightly labor shows just how much precision matters. A worn-out trap simply isn't good enough. The spider would rather recycle its materials and rebuild than gamble on an aging web for its next meal. A spider's 8 legs move using hydraulic pressure as much as muscle. That strange fact explains part of their distinctive way of moving. Spiders do have muscles capable of pulling their legs inward, but extending certain leg joints works differently. Rather than relying purely on opposing muscle pairs, the spider pushes fluid pressure outward through its body, effectively operating part of itself like a small internal hydraulic machine. This is why a spider that has died often curls its legs inward. The fluid pressure disappears, leaving only the inward pulling muscles in control. In life, though, that hydraulic system allows for quick, precise extension while walking, climbing, and lunging, an elegant solution to a structural challenge, especially inside such a compact body. Many spiders effectively taste the world through sensitive hairs covering their legs. A spider doesn't need to bring food to its mouth to begin gathering information about it. Its body is lined with sensory structures, and some of the most important of these sit along the legs and feet. The moment a spider touches a surface, chemical signals can be detected almost immediately, meaning a strand of silk, a leaf, or a patch of bark can offer information before the spider commits to anything further. This helps it identify prey, recognize traces left behind by other spiders, and judge whether a location is familiar, promising, or risky. For us, taste belongs strictly inside the mouth. For a spider, the line between tasting and touching is far blurrier. Every step becomes a kind of investigation, and every contact gathers new detail. Certain spiders hunt along the water's edge, feeding on small aquatic creatures. The margin of a pond or stream isn't simply a boundary between two worlds. For these spiders, it's a hunting ground rich with opportunity. They wait on stones, floating vegetation, or shoreline debris with legs spread wide enough to detect the faintest ripple. A struggling insect, a tiny tadpole, or a small fish breaking the surface sends vibrations rippling through the water, and the spider reacts with startling speed, seizing prey from a realm many people assume lies beyond its reach. The diving bell spider spends nearly its entire life submerged underwater, a species that, rather than avoiding water, has made it into a permanent home. It lives in ponds and slow-moving waters, constructing a silken chamber among submerged plants. This chamber functions as an underwater air room. The spider repeatedly swims to the surface, traps a bubble of air against its body, then carries that bubble down and releases it into the chamber. Trip after trip, the structure grows until it holds enough air to support resting, feeding, mating, and even guarding eggs. Inside that hidden dome, the spider lives suspended beneath the surface while still breathing the same atmosphere we do above ground. Boa spiders hunt using a sticky thread swung like a tiny lasso. Instead of building a broad trap and waiting, the female releases chemical scents that mimic those of a female moth, luring hopeful males toward her. As one approaches, she hangs from a silk line and swings a short thread tipped with a sticky droplet. a weapon requiring exact timing. If the moth comes close enough, the droplet catches it, and the spider reels in her catch. This is hunting built entirely from deception, chemistry, and precise control. Spitting spiders can launch a combined spray of silk and venom in a single strike, gluing prey in place while simultaneously poisoning it, all without ever needing to make direct contact first. From glands near the head, the spider ejects a sticky mixture in rapid, oscillating streams, laying down a tangled pattern over its target before moving in for a closer approach. This lets the spider maintain a safer distance from prey that might otherwise bite, sting, or fight back with enough force to cause real injury. Crab spiders ambush unsuspecting pollinators by hiding in plain sight inside flowers. A flower can look like the safest place imaginable, bright, open, full of nectar. For a crab spider, it becomes the perfect blind. These spiders sit motionless among the petals, front legs spread wide, waiting for bees, flies, or butterflies to land. Some species match the color of the bloom so precisely that they seem to dissolve into white, yellow, or pink. The moment a visitor arrives, the stillness ends instantly, and the spider seizes its target before it can lift away again. Some spiders have evolved to mimic ants so convincingly that predators are fooled outright. Ants are difficult prey, capable of biting, stinging, swarming, and defending themselves with a ferocity that far exceeds their size, which makes resembling one an incredibly useful disguise. Certain spiders have developed narrow bodies, dark coloration, and movement patterns that make them look startlingly ant-like at a glance. To birds, wasps, and other predators, that resemblance alone can be enough to trigger hesitation or disinterest. Some of these mimics even lift their front legs and wave them like antennae, since spiders don't have any of their own. A piece of pure illusion built entirely from posture and motion. A few orb-weaving spiders decorate the centers of their webs with bold, mysterious zigzag patterns known to scientists as stabilimenta. Their exact purpose remains debated. They might make the web more visible to larger animals to prevent damaging collisions. They might attract prey by reflecting light unusually, or they might help camouflage the spider resting among the strands. What makes them fascinating is that a spider is adding something beyond the basic trapping geometry, a visible flourish whose true meaning still isn't fully settled. Some web patterns reflect ultraviolet light in ways that certain insects find impossible to resist. To our eyes, a web may look faint or nearly invisible in sunlight. Many insects, however, see a different spectrum entirely, one that reaches into ultraviolet wavelengths, and certain silk patterns reflect that light strongly enough to stand out vividly to them. This may explain why some webs remain effective even when they appear obvious to us. What looks subtle to human eyes can glow like a beacon to an insect's brain. Spiders were among the very first animals to establish life on dry land. Long before forests reached anything resembling their modern complexity, before birds, mammals, or flowering plants existed at all, early arthropods were already pushing out of the sea and onto solid ground. Among them were the ancestors of spiders, helping pioneer an entirely new kind of existence away from water. That transition was enormous. Land offered fresh air, open space, and untapped prey, but it also brought the threat of drying out, unstable temperatures, and the challenge of gravity without the buoyant support of water. To survive, these early pioneers needed bodies capable of breathing, moving, sensing, and reproducing in a radically different environment. Fossilized spiders have been discovered perfectly preserved inside ancient amber. Amber is far more than a golden curiosity. It's time made visible. When flowing tree resin once oozed over bark and forest debris, small creatures could become trapped inside it, and over vast stretches of time that resin hardened into amber, sealing its captives in extraordinary detail. Spiders preserved this way can still reveal delicate legs, distinct body shapes, and occasionally even traces of silk. Looking into a piece of amber can feel like peering through a window into a vanished forest, watching a moment frozen for millions of years. Some spiders can survive for months without eating a single meal. For an animal built around catching small, unpredictable prey, that kind of endurance is extraordinary. Weather shifts. Insects vanish with the changing seasons. A burrow may sit empty for long stretches, or a web may hang untouched night after night. Rather than burning through energy recklessly, many spiders are built for long periods of patient waiting, Their metabolism slows, their activity drops, and their bodies stretch limited reserves across astonishing lengths of time. Tarantulas can live for decades if they manage to avoid danger, which is a striking fact for an animal many people imagine as short-lived and frantic. In some species, females can survive for several decades, spending years within the same burrow or territory, growing slowly and simply waiting for opportunity to come to them. That kind of longevity fundamentally changes how we should picture these animals. This is not a creature defined by brief bursts of activity, but by patience made flesh. Female spiders are often dramatically larger than males, and in some species the size difference is so extreme it looks almost as if the two belong to entirely separate species. The female often needs a larger body to produce eggs, defend territory, and subdue substantial prey, while the male is frequently built instead for travel timing and calculated risk. He must locate her, approach cautiously, and survive long enough to actually mate. Some male spiders court potential mates by drumming, tapping, or plucking at the strands of a web. Courtship for many species is less like a casual meeting and more like a carefully coded performance delivered on the edge of real danger. A male cannot simply rush toward a female and hope for the best. If he seems too much like ordinary prey, the encounter can end badly for him. So instead, many males announce themselves through vibration, tapping the surface beneath them, or plucking the strands of a female's web in specific rhythmic patterns that signal identity and intention. A female may be able to tell from these signals alone whether her visitor is suitable, unfamiliar, or genuinely dangerous. Jumping spiders possess remarkably sharp eyesight for creatures of their size. Most spiders rely heavily on vibration to sense their surroundings. But jumping spiders are visual hunters through and through. Their large, forward-facing eyes provide detailed sight that helps them judge distance, track moving prey, and navigate complicated environments with real confidence. They don't simply lunge at anything that twitches nearby. They study, aim, and choose their moment. Some species can distinguish colors and shapes with a level of clarity that's rare among animals their size, which helps explain why their behavior can often seem so deliberate and, at times, almost curious. A tiny spider preparing to disperse into open air is one of the strangest departures found anywhere in the animal kingdom. There's no roar, no leap, no beating of wings, only a pause, a lift, and then a sudden disappearance. A spider reaches the tip of a blade of grass or a fence post, tests the surrounding conditions, and releases threads so fine they're barely visible even in bright daylight. If conditions are right, those threads pull taut and the spider lets go, becoming airborne within seconds. For the spider, this is simultaneously transport, escape, and exploration. Spiderlings use this method to disperse from crowded hatching sites, and even adult spiders of smaller species sometimes take to the sky after storms or habitat disturbances. Some spiders appear capable of recognizing landmarks and planning surprising detours while hunting. A jumping spider may spot potential prey from one vantage point, then realize there's no direct path toward it. Rather than giving up, it can move away from the target entirely, disappear behind leaves or stems, and take a longer route that eventually leads to a better attack position. In laboratory studies, some spiders have chosen the correct path among several options, even when a more obvious direct route looked tempting but ultimately led nowhere useful. Behavior that starts to feel less like simple reflex and more like genuine tactical decision-making. Some spiders respond to sudden danger by feigning death entirely. Certain species react to threat by going completely limp, folding their legs inward and becoming so still that they appear dead or simply uninteresting. For a predator triggered mainly by movement, this can interrupt the entire attack sequence at exactly the right moment. Others defend themselves by shaking their webs so violently that both spider and structure blur into an indistinct haze. When disturbed, certain species vibrate at astonishing speed, making themselves extremely difficult for a predator to focus on or strike accurately. The web itself becomes part of the defense, amplifying the motion into a flickering wall of silk and shadow. Net-casting spiders hunt using a small woven net stretched between their front legs. They hang upside down at night, holding this rectangular mesh like a fisherman with a handheld net, waiting patiently in the dark. When an insect passes below or nearby, the spider lunges and throws the net forward in a single rapid motion, stretching it over the prey and expanding on impact to help secure the catch before it can escape. Ogre-faced spiders can strike in complete darkness with unnerving precision, thanks to enormous forward-facing eyes built for gathering the faintest available light. By day, this spider may remain stretched motionless along a twig, nearly impossible to spot. By night, it becomes a poised, highly effective hunter, holding its woven net ready and reading the darkness with remarkable accuracy. Some spiders may be able to sense and even make use of the Earth's natural electric field when preparing to take flight on silk. Experiments suggest that fine threads can respond to ambient electric charge, rising and spreading in ways that help generate lift even when the wind itself is weak, meaning a spider preparing to balloon into the sky might be responding to far more than a simple breeze. Ballooning spiders have actually been detected thousands of feet above the ground, carried aloft on threads into airspace wildly out of proportion to their tiny bodies. This helps explain how spiders can appear so quickly in remote locations, on islands, in newly disturbed fields, or in habitats that seem freshly emptied. They don't always arrive by crawling step by step. Sometimes they simply arrive from the sky. A spider web can stretch, flex, and absorb powerful impacts without tearing apart. This resilience is part of what makes silk so remarkable as a material. If a web behaved like a rigid fence, the very first fast-moving insect would tear straight through it. Instead, the structure gives way at exactly the right moments, distributing force through its connected strands and slowing impact rather than resisting it outright. Silk produced by a single species can serve wildly different purposes depending on the task at hand. One type may support the spider's own body weight. Another forms the structural frame of a web. Another wraps struggling prey securely, lines a hidden retreat, anchors a clutch of eggs, or acts as a safety line during a sudden fall. A single spider may simultaneously produce dragline silk for structural support, sticky glue silk for its capture spiral, and separate wrapping silk designed purely to immobilize captured prey. Distinct materials, each engineered for a distinct purpose, all produced by the same small body. Spider adhesive is specifically built to hold firm even against desperate, frantic struggling. A captured insect doesn't surrender quietly. It kicks, twists, and beats its wings with everything it has. Yet the sticky droplets found on capture silk are designed for exactly that chaos, stretching and clinging as the prey fights while the surrounding structure absorbs and redistributes the resulting motion. Many orb-weaving spiders recycle their own old silk by consuming it before rebuilding. Rather than wasting valuable protein, they reclaim it directly, turning the web into something wonderfully cyclical, built, used, partially eaten, and then turned toward the very next version of itself. A web functions simultaneously as trap, shelter, and extended sensory organ. For many spiders, it marks out a genuine living space, a suspended home where the animal can rest, retreat, and monitor its surroundings without wandering openly through them. Every tremor along its strands carries potential meaning: a trapped insect, an approaching mate, or a dangerous intruder, each producing a distinct pattern of vibration that the resident spider must interpret correctly and quickly. Some cave-dwelling spiders have lost much of their eyesight altogether. In deep, permanently dark cave systems, vision becomes a poor investment, and over long stretches of evolutionary time, certain species have developed reduced eyes in favor of heightened touch and vibration sensitivity. Meanwhile, other spiders thrive in blazing deserts where extreme heat would overwhelm most animals, surviving by sheltering in burrows, hunting during cooler hours, and moving with startling speed across sand that would otherwise scorch them. Some spiders are remarkably social, living together in colonies that can number in the thousands. Rather than defending fiercely isolated territory, these species tolerate one another, feed side by side, and raise young within a shared structure. These colonies can construct enormous communal webs draped across entire shrubs or small trees, creating a ghostly tent-like structure where thousands of connected strands link resting areas, nurseries, and shared capture zones. Not every spider hunts for its own meal. Some steal food directly from another spider's web instead, slipping in to snatch trapped insects or feed at the edge of someone else's catch. Pirate spiders take this a step further, specializing in invading another spider's web entirely and preying on the resident itself, using careful vibrations to avoid detection before striking. Certain predatory spiders go even further still, plucking silk in patterns that mimic the exact movements of trapped prey, luring the unsuspecting web owner directly into a trap, disguised as an easy meal. Some spider mothers produce unfertilized eggs purely to serve as an early food source for their newly hatched young, a deliberate act of biological investment rather than any kind of waste. In a handful of species, mothers even produce a nutrient-rich, milk-like fluid that spiderlings consume during their earliest days of life, extending parental care far beyond what most people expect from these animals. In the most extreme cases, some mothers ultimately allow their own bodies to become the final meal for their offspring, delivering one last powerful burst of nutrition just as the spiderlings begin their independent lives. Freshly hatched spiderlings often begin life clustered closely together near the egg sac, sharing origin and space in a moment of surprising closeness, a peace that is often temporary. As they grow, territory and competition begin to matter more, and siblings that once moved together can become wary rivals, each needing to claim enough space and food to survive on its own. Some male spiders present carefully wrapped prey as a courtship gift before approaching a female, using the offering both as a genuine meal and as a signal of their own value, hopefully occupying her long enough to mate safely. Other males risk becoming a meal themselves if their timing or signals are wrong, since courtship in many species carries real danger from start to finish. A single miscalculated movement can shift the entire encounter from romance to predation in an instant. Jumping spiders can distinguish colors with real precision, helping them detect prey, recognize rivals, and interpret courtship displays that would lose much of their meaning in a colorless world. At night, the eyes of certain hunting spiders can shine with an eerie, beautiful glow when caught in torchlight, a reflective layer inside the eye, returning available light in a way that makes them gleam like scattered points of green or silver fire across otherwise empty-looking ground. Web-building spiders exercise remarkable control over the tension of their threads, adjusting anchor points, thread lengths, and overall structure to achieve exactly the right mechanical balance for their environment. A damaged section of web can even reveal exactly where and how prey managed to escape, the torn geometry recording the encounter almost like a set of tracks left behind after a struggle. Spiders provide an enormous, largely unseen benefit to agriculture, devouring vast numbers of crop-damaging insects across fields, orchards, and hedgerows every single day and night, all without engines, chemicals, or any human supervision at all. Scientists estimate that, taken together, the global spider population consumes an almost unimaginable mass of prey each year, quiet, continuous, and easy to overlook, yet enormous in its cumulative ecological impact. Even ordinary city gardens support surprisingly skilled populations of these hunters, each one practicing ancient survival techniques among paving stones, planters, and garden fences. Many spiders live quietly inside human homes without ever being noticed, occupying small corners, shelves, and ceiling edges where insects also happen to pass through, sometimes remaining in the very same spot for the majority of their lives. A spider is able to walk across its own web without becoming stuck to it, a feat that seems almost magical until you understand the mechanics behind it. Not every strand of a web is coated in adhesive. Many serve purely as structural, dry pathways, and the spider moves with precise awareness of exactly which strands are safe to touch, placing its feet carefully to avoid the freshly glued capture spiral. Certain spiders hunt by sensing the faint air movements produced by beating insect wings, detecting prey before it ever makes physical contact with silk or ground. Others ambush entirely from concealed burrows, keeping only their front legs exposed at the entrance as sensory feelers, striking suddenly from what looks like empty ground. Tarantulas native to the Americas can flick tiny, irritating barbed hairs into the air as a defensive cloud, using their own bodies as a source of airborne deterrent, rather than relying purely on biting to fend off a threat. Meanwhile, certain spiders disguise themselves so convincingly as bird droppings that most predators won't even bother investigating them, relying on disgust rather than invisibility to stay safe. Others flatten themselves against bark or twist their bodies to resemble broken twigs and dead leaves, dissolving almost entirely into their surroundings. Some tropical spiders reinforce their unusually large webs with additional stabilizing lines, helping the structure withstand wind, heavy impacts, and the general strain of supporting an oversized capture area. Certain species can even survive brief flooding by trapping a thin layer of air around their bodies using specialized hairs, creating a shimmering, temporary air supply underwater. A few shoreline-dwelling spiders use the surface tension of water itself as a hunting platform, balancing delicately while sensing prey moving at or just below the surface. Spiders lack ears in the conventional sense, yet many can still sense sound through vibrations carried by air, ground, or silk, detecting an approaching predator, a calling mate, or disturbed prey without anything resembling the ear structures found in mammals or birds. Certain species may even be able to detect polarized light patterns in the sky, gaining directional orientation cues even when the sun itself is obscured, potentially useful information when preparing to launch into the unpredictable process of aerial dispersal. Newly hatched spiderlings are often already equipped with venom, silk, and hunting instinct, entering the world as functional miniature predators almost immediately rather than passing through any extended period of helplessness. Much of a spider's venom serves a digestive purpose rather than a purely defensive one, beginning the breakdown of captured prey from the inside so that the spider can consume the resulting liquefied nutrients rather than solid tissue. Since spiders do not chew their food the way many other animals do, the largest spider species are capable of overpowering prey far larger than typical insects, with some heavy-bodied hunters known to occasionally subdue small frogs, lizards, or even mice when the opportunity arises. In rare instances, tropical spiders have been observed catching small fish along the margins of streams and ponds, and in exceptionally rare cases, large orb webs have even been found holding small bats that flew into them at exactly the wrong angle. Certain spiders survive freezing nights by altering their internal body chemistry, producing natural antifreeze-like compounds that lower the temperature at which damaging ice can form inside their tissues. Others thrive in extreme high-altitude environments above the tree line, sheltering among rocks and low vegetation despite thin air, brutal wind, and near-constant cold. Some species have even adapted to life inside caves, lava tubes, and deep rock crevices, occupying ceilings and cracks where insects occasionally pass through, sometimes evolving pale coloration or unusually long legs suited to a life spent almost entirely in darkness. A web's silk can even carry a subtle static charge that helps draw nearby prey inward, since flying insects often build up static electricity through friction with the surrounding air. As an insect approaches, mild electrostatic attraction may cause threads to shift slightly toward it, increasing the odds of contact, meaning the web is never entirely passive, even in an encounter that looks purely mechanical from the outside. Young jumping spiders have even been observed entering restful states at night, marked by twitching legs and shifting eyes beneath their outer surface, leading some researchers to cautiously compare the behavior to dream-associated sleep phases seen in other animals. Though no one can say for certain what, if anything, a spider actually experiences during these episodes. Some spiders appear capable of memorizing useful landmarks along a familiar hunting route, using remembered features of their environment to navigate more efficiently through what is, from their perspective, a genuinely three-dimensional maze of stems, leaves, and open gaps. And many display real behavioral flexibility, capable of abandoning one hunting strategy mid-attempt and shifting to another entirely when circumstances change unexpectedly. The webs built by different species can be so distinctive that trained experts can identify exactly which spider constructed a given structure simply by studying the spacing of its spirals, the angle of its frame, and other small architectural details, silk functioning almost like a signature left behind by its maker. And within a single ordinary meadow, thousands of spiders may be quietly hunting at once, spread between grass stems, soil, and flower heads, forming a dense and layered hunting ground that mostly goes completely unnoticed by the world above it. For thousands of years, human cultures loaded spiders with meaning, treating them as omens, tricksters, symbols of patience, and figures lurking in shadowed corners. And yet modern research hasn't made them seem smaller or duller. It has done exactly the opposite. The closer scientists examine spiders, the stranger and more remarkable they continue to become. Their silk is inspiring new developments in medicine and engineering, from surgical materials to lightweight, high-performance fibers. Their webs are teaching researchers how to build structures that are both sensitive and resilient, absorbing stress gracefully rather than breaking under it. At a distance, a spider can seem easy enough to sum up. 8 legs, some silk, a bite, and a long-standing reputation. Look closer though, and that simplicity falls apart completely. There are spiders that fish, spiders that glide for miles on invisible atmospheric currents, spiders that perform dazzling color displays, spiders that build their own private air chambers underwater, spiders that disguise themselves as ants, as twigs, even as bird droppings, spiders that live in enormous cooperative colonies, and spiders whose nightly rest may include mysterious twitching eye movements we still don't fully understand. Even the most familiar parts of their world turn out to be stranger than expected once examined closely. Silk isn't simply thread, it's an entire toolkit of specialized materials. A web isn't simply a net, it's a sensory instrument, a home, and a trap all at once. Venom isn't simply a weapon, it's often the very first step of digestion itself. Each layer of understanding only opens up another, deeper layer of mystery, which is exactly what makes spiders such an endlessly rewarding subject for scientific curiosity. They refuse to stay contained within the narrow mental boxes people tend to build for them. Spiders are not simply creeping, unsettling little creatures to be feared and swept from a corner. They are, in every meaningful sense, evolutionary masterpieces, the product of hundreds of millions of years spent refining solutions to survival that are elegant, endlessly varied, and often astonishingly advanced. They have mastered a material humanity still cannot fully replicate. They have settled deserts, rainforests, mountain summits, deep caves, and the quiet corners of our own homes. They hunt using webs, leaps, ambushes, disguise, vibration, and boundless patience. Many raise their young with a depth of care that defies expectation, and they sense the surrounding world through systems that make our own human assumptions feel narrow and incomplete. None of this belongs to a crude, simplistic animal. It belongs to a lineage shaped by relentless refinement across an almost unimaginable stretch of time. And once you see it that way, the old stereotype quietly falls apart. What once frightened people at first glance reveals itself, on closer study, to be one of the natural world's finest and most enduring achievements. As our journey through this hidden world begins to wind down, perhaps spiders feel just a little different to you now. Not simply shapes lurking in corners or silhouettes caught in a web at dusk, but ancient hunters, master engineers, patient travelers on the wind, and tiny survivors carrying millions of years of quiet invention in every thread they spin and every careful step they take. We've wandered together through moonlit webs and hidden burrows, across flower petals and still pond edges, into deep caves, sun-scorched deserts, quiet forests, and even the open sky itself. We've met spiders that dance, spiders that fish, spiders that raise their young with startling tenderness, and spiders that transform silk into traps, lifelines, shelters, and quiet signals passed along invisible threads. Perhaps that world feels a little larger now, a little stranger, a little more beautiful than it did before. The fence at the edge of a garden, the quiet corner of an attic, the tall grass at dusk, these are no longer simply empty spaces. They're part of a living, breathing map, filled with trembling threads, patient hunters, and countless small lives quietly unfolding just beyond the edge of our attention. For now, let all of that gently drift into the background. Let your breathing slow further still. Let your shoulders loosen completely, and let these images fade softly from anything sharp or vivid into something quieter and more distant, like dew resting on a web just before sunrise, before dissolving gently into the morning light. If this quiet journey brought you any comfort tonight, feel free to like the video, subscribe, or leave a thought in the comments below. It helps other tired, curious minds find their way to this same peaceful corner. And if you happen to still be awake, there's always another journey waiting for you, another world to wander into slowly and gently, whenever you're ready. But for now, let your mind grow still, and let the day quietly fall away. Sleep well, and good night.